Lesson 12, elliptical type. Find the locus of a point that moves such that its distance from the point 4, 0 is half its distance from the line x equals 7. Not equal, but half. So this will generate a different sort of conic. In fact, it's an ellipse. We'll find out it's an ellipse when we work this all out. So we'll go through the same process. We'll work out what SP is equal to. By the way, this is quite advanced, this one. It's in the Extension 2 course in the New South Wales Higher School Certificate, but you can work it out in the 2-unit course from First Principles, of course. So SP is equal to the square root of x minus 1, or x minus 4, all squared, plus y squared. And of course, PD is equal to, now that's just going to be 7 minus x. So it's pretty much the same. Except at this point here, rather than make them equal, we know that PD, this distance PD, must be twice SP. So we'll do that. We'll go the square root of 7 minus x equals 2 times the square root of x minus 4 all squared plus y squared. Okay, so squaring both sides, we get 7 minus x all squared equals 4 outside of x minus 4 all squared plus y squared. Now at this stage we could actually expand all that out and would have some sort of locus, but I'm going to manipulate this a little bit just so you can see a nice sort of symmetry coming out of it. We'll change that to an x minus 7 to make the algebra easier. Now I'll write this as 4 into x minus 4 all squared plus 4y squared. What I'll do here, again to make the algebra easier to work with, I'm going to take that 4 inside, but to do that I'll have to change that to a 2. So that will be a 2x minus 8 all squared. You see that? So if I take out a common factor of 2, I'll have to square it to make it a 4 to get it out again. Plus 4y squared. Alright, now the next thing, I'm going to take this one across to this side. Alright, this is 2x minus 8 all squared minus the x minus 7 all squared plus 4y squared. Again, our difference of two squares is happening, so we got 2x minus 8 plus x minus 7 and 2x minus 8 minus x plus 7. Watch the sign again. Plus, that should be equal 0, plus 4y squared equals 0. This becomes 3x minus 15. Okay, and this becomes x minus 1 plus 4y squared equals 0. I'm going to take out that 3 there and write it like this. Dividing through by 3, I get x minus 5, x minus 1 plus 4/3 y squared equals 0. Now remove the brackets. X squared minus 6x plus 5 plus 4/3 y squared equals 0. You can see why this is quite an advanced one. Take the 5 across the other side. And now I'm going to complete the square. So halve that, minus 3 squared, 9. So add 9 to both sides, forming this into a perfect square. So that becomes x minus 3 all squared plus 4/3 y squared equals 4. Now I'm going to divide both sides by 4. You'll see a really lovely bit of symmetry coming out of this. So it's x minus 3 all squared over 4 plus, now this 4 cancel, y squared on 3 equals 1. Now that's in the form of an ellipse. Now the form it takes is this. It's x minus h all squared on a squared plus y minus k, this time k is 0, all squared on b squared is equal to 1. Now, what we can do here is we go back to our original thing. I'll better write this back up here. Let's remember x minus 3 all squared on 4 plus y squared on 3 equals 1. Now, in drawing this, if we let x equals 3, when x equals 3, which is here, we can see that y squared is equal to 3, or y equals plus or minus root 3. This is known as the minor axis. So it goes up here about, right now, root 3 about there somewhere, I guess, and then down here somewhere. So that point there would be 3 minus root 3, and this little one up here is 3 root 3. Now, when we make y equal 0, y equals 0, we can see that x minus 3 all squared equals 4. So x minus 3 equals, take the square root, plus or minus 2. So x will equal 5, which is there, and you see there's the ratio happening, 1 to 2. There it is, 5, 0. And the other point here will be 3 take away 2, which is 1 over there. Right, so this 3, 0 was the actual centre of our ellipse. I'll just draw another colour. Not really good scale here. It's almost like a circle, but it's not. Oh, very bad. You can practice it later yourself and see how nice this is. And there you go. That's generating the ellipse. Now, I've just done one. I haven't done there's a hyperbola as well, but that goes the other way. So if you if the point was twice the distance from x equals 7, then you'll get a hyperbola. And no doubt the Extension 2 students would do this. It's a great pity, you know, that apparently the national curriculum is going to take the conic section out of the course in the next couple of years. And well, I think it's quite a shame, really, because you get some beautiful things happening with conics. I'm sure a lot of Extension 2 teachers would agree with me.